Hello Year 12, welcome to the 8th video here for our 9th topic. We're looking at network flow problems today. Now this is going to be a weighted directed network graph that we're looking at, or a weighted directed network anyway, but we're going to be looking at a graph, and we are going to be going from one end to the other, and we're going to try to find the maximum, typically the maximum amount of stuff that I can get from one to the other. Now I find it helpful to think about these things perhaps as a network of drains, and the water's only going to flow downhill. Okay, gravity fed, it's going to go from the source, which is abbreviated to S typically, to the sink, which is typically abbreviated to T, and it can only go one direction here because it's got to flow downhill. Now, the way that we're going to do this for the time being, the flow capacity, we're going to calculate the flow capacity. The way we're going to do it is we are going to systematically look at each path and keep reducing the amount of capacity along those edges until we can no longer find a pathway from the source to the sink. This will take a little while. We need to be fairly systematic about it. And I've just spent about 15 minutes doing this and got the wrong answer because I'd made some sort of mistake that was very hard to trace. So be careful with these things. Hopefully this time a bit more luck. So I'm going to consider some different pathways here. I'm going to begin by looking at S to A to T. In fact, I'm just going to use some sort of system where I try to stay towards the top of the page as much as possible. Now if I go from S to A to T, my maximum flow along that route, or that path, is 180. Right, 180 along here. There might be room for 200 there, but I'm not going to use it. So, right, I'm going to cross out the 180. That's all used up. The 200 will have a capacity of 20 left. And in fact, I'm also going to put a bit of a squiggly line along this edge to say that there is no, we can't use that anymore. Right, that's completely used up, and I've managed to get 180, oops, it's always go funny, 180 units from the source to the sink. Okay, now I'm going to try this pathway here from S to B to A to T. Right, as I said, I'm going to keep aiming towards the top of the page. Now if I follow S to B to A to T, eventually I hit this bottleneck here with the 20. So along that pathway, SBAT, I can only get 20 units before that edge AT is at full capacity. I'm just going to scribble it out again. So we can put another 20 in here, and I need to reduce these things here, right? That now becomes a 280. Right, this one now becomes 190 left. This one here becomes 100 and, oh, no, wait, I haven't used that one. Let's just go back a step there. It's going to work. Okay, let's just leave that for the time being. We'll fix it up in a moment. So we have, is that right? I've taken 20 off here and here, and then we made our way along there. So far we've got 200 units from start to finish. But we still have a lot more capacity here. So now I'm going to consider this pathway here from S, where's my cursor here? From S to B to A, right, now I'll have to come back to C, and then D and T. So if I follow that pathway, S, B, A, C, D, T, right, the sort of the narrowest constriction there is this 190 here. So this next pathway, I'll get another 190 units long. Oops, something's not quite right there. Okay, so if I take 190 away from the 280, I'm left with 90 from S to B. Now AB is now fully used up. I'm just going to scribble that out to remind me, can't use it anymore. That 200, right, we've just used 190, leaves me with a capacity of 10 left on AC. Now, that 350, we've used up 290, so that leaves me with 160. And this 650, we've used up 190, so that brings it up to 460 left there. And don't forget to add another 190 onto your list of achievements, right? We've got another 190 units now from the source to the sink. Now I'm having a look and seeing what other pathways can I find from my source to the sink. I could still go straight down the middle, but can you see that while there's still 10 units of capacity along AC, right, there's no way to get to A anymore. I can't get to the predecessor. So I think we're going to see, I'm just going to put a loop around here to say, whoops, there's still a 10 there. I kind of scribbled it out there, it's a bit messy. But I don't think I'm going to get anything more out of that edge. Right, there's 10 sort of wasted capacity there. But from S to B to C to D to T, the smallest number along that route is the 90 here. So let's reduce each of those by 90. I'm going to scribble this one out to remind me that I've used that completely up now. This one here, I use up 90, I've got 60 left. I use up 90 here, I've got 70 left. I use up 90 here, and I've got 370 left, and I need to add a 90 to my list. Okay, now to get from my source, the only way is to go from S to E to begin with. That's fine, that's a 400. There's still quite a lot of ways to go. So I'm going to go SE, EC, CD, and then DT. Right, maintaining this strategy of keeping towards the top of the page. Now again, notice that BC, like AC, right, the predecessor of this edge is this edge. I can't get to B anymore. All of those edges are full. So I'm just going to circle that. You don't have to. Just as a sort of reminder that I can see that edge now is unavailable to me. But 400, 150, 70, 370, we're going to take 70 off each of these along this pathway. That becomes 330. 70 off this becomes an 80. 70 off this, and I'm done. CD there is all used up. Righto, and 70 off here is 300. Righto. And what did I just do? Another 70. So let's put a 70 over here. Righto. Now, how can I still get from my source to the sink? I can no longer get along CD. So the only pathway now is via FD. Right, that's my only pathway. I can see EC, right, while my sort of predecessors there aren't used up, I can't get anywhere afterwards. Right, the only thing that comes after EC is CD, and that's all used up. So now my only pathway will be SE, EF, FD, DT. The smallest number along that pathway is a 250 here. Okay, so I knock 250 off there, and I'll get 80. I use up that 250, all gone, and we'll just take this edge out of commission now. 250 off here is with, oops, is with 210. 200. That doesn't look at all like a 210. Let's get rid of that. Leaves it at the 210 here, and I was getting rid of 250. Leaves it at the 50 there. Okay, so another 250 onto my list. Okay, and now I can see that, right, while not all of my edges are used up, I can no longer find a way from the source to the sink. In fact, right, if we look at this very carefully and do a bit of analysis, we might recognize that if I look at a pathway sort of through here, an imaginary line there, that there's no way left to cross that line. Now, that's something for the next exercise. But we can, that should tell us that there's no way to get from the left of that line to the right of that line anymore. So that's it. I'm all full up. Now, to work out flow capacity, I'll need to add up all of these paths that I found. So 250 and 70 is 320, and 410. 500, 600, 620 brings me to a total flow capacity of 800. What is the flow capacity of this network? My flow capacity is 800, and I know that's the correct answer, and I'm so pleased to get there. Look, there is a bit of work in doing that. I hope it has been successful. We could begin to talk about the next one. Should we do that? Yes, we can. Now, a cut is an imaginary line that passes through edges, not vertices, and separates the source from the sink. You know what? You know what? That imaginary blue line we just drew in there is what we call a cut. Okay, it's a line. It cuts through the network, just through edges, and it sort of has to cut through enough that you can't get around it anyway. It separates the source from the sink. There are lots of different cuts I could do. I could put a cut. Let's see if I can use my sort of point here. I could put a cut through here, right? That would separate the source from the sink. I could put a cut through here, right? That's slightly different because I'd be cutting the edge FD instead of EF. Right? I could put a cut here. I could put a cut through here, through here. There are very many cuts that I could make here. There are many cuts that I could make. Now, a cut like this, right, or a line like this, that's not a cut, because I can still find a way from S to T. I've isolated A from the network, but not the source from the sink. So that's not what we refer to as a cut. Cut has to separate the source from the sink somehow. Rightio. Well, to work out the capacity of a cut, we add up all of the edges, right, along the cut, but only those ones that go from the source to the sink. Right, when I make a cut, sometimes we'll be cutting an edge that goes the opposite direction. Now, we don't, something that crosses my cut from the right to the left. We don't include that in the capacity of the cut. Now, we've got a couple of, we've got one more example to do here. The video is getting long, but nonetheless, we'll be fine. Let's have a look here quickly. Cut 1, capacity of 1. Now, 40 goes from left to right, and the 70 goes from left to right. So cut 1 has a capacity of 110. I'm just going to write it here, nice and easy, right? These aren't so hard. Cut 2, 35, and the 50. I don't include the 80 because, see, it is going from right to left. So 35 plus 50 is 85, plus this 70 is 155. Okay, that's cut 2. Cut 3, 35, plus 50 is 85, plus 45 is a 130. 130. And finally, cut 4, 35, plus 50 is 85. Oops, always with the 8s. Okay, is 85. And that's it. That's the idea of a cut. Its relevance will become a more significant in our next exercise. But for today, we were looking at network flow problems, right? And we, at least at this stage, we calculated the flow capacity of a network, right, by looking at a raft of different paths from the source to the sink. Okay, it was a slow and at times messy process. We are going to look at a much more efficient way of doing that later on using cuts. Yes, but that's it for today's exercise. If you've got any questions, you know what to do. Jot them down. See me in class. Thanks very much.